Welcome to True Projects. In this video, we are going to explain about a project titled Stock Market Prediction Using Deep Learning. The stock market poses the significant challenge to investors and traders due to its dynamic and intricate nature. To address these challenges, we embark on an ambitious journey harnessing the potential of the deep learning technique to revolutionize the stock market prediction. Through the application of advanced deep learning algorithm, our aim is to create a sophisticated predictive model capable of accurately forecasting the stock price trends. In our project, we integrate the historical market data with real-time information to gain the valuable insight into the market behavior and the fluctuations. By doing so, we equip the investors with the tools they need to make more informed and timely investment decisions. Our primary objective is to enhance the financial decision making, minimize the risk, and optimize the return in the ever-changing world of stock market. Through the data-driven prediction, we strive to empower the trader and the investor, providing them with the valuable resources to navigate the complexity of the stock market effectively. By pushing the boundary of the stock market prediction, our project seeks to create a more efficient and rewarding experience for all the participants in the market. The objective of this project is to develop an all-encompassing and the precise stock market prediction system, revolutionizing the way investors approach financial decisions. By harnessing the potential of the cutting-edge deep learning algorithm, including LSTM, ANN, Simple RNN, and GRU, we aim to construct a robust predictive model with exceptional forecasting capabilities. In the heart of our project lies the analysis of the historical stock market data to make the accurate prediction of the future price trend. Our primary mission is to equip the trader and the investor with a valuable insight into the market behavior, empowering them to make well-formed decisions and optimize the investment strategy. Through intensive training and the optimization of this advanced deep learning algorithm, we envision building a reliable and efficient system that surpasses the traditional stock market prediction approach. Our ultimate goal is to contribute to a more successful and rewarding stock market experience, supporting the investor in making the sound financial decision and maximizing their return and the dynamic and the challenging domain. Embracing the innovation, our project endeavors to redefine the stock market prediction, elevating the potential for the financial success and the investor confidence. These are the basic requirements that are needed to build this project. Software requirement: Python IDEL with version of 3.7, Anaconda with version of 3.7, or Jupyter. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. And we import the essential libraries such as Pandas, NumPy, TensorFlow, and Keras. These libraries offer powerful tools and functions necessary for data processing, manipulation, and building the deep learning model. And the second one is importing the dataset. We gather the historical stock market dataset for the SPI and Tesla from the reputable sources. The dataset include the information such as date, opening price, high, low, closing price, and the trading volume. By importing and analyzing this data, we can establish the pattern and the trend to develop the accurate predictive model. And the third one is building the model. To create the robust stock market prediction system, we employ various deep learning architecture. The first one is LSTM. It stands for Long Short-Term Memory, specialized recurrent neural network with a remarkable ability to handle the sequential data effectively. In the context of our stock market prediction project, LSTM strength lies in its capability to capture the long-term dependency in the time series data. This characteristic is particularly valuable for the stock market prediction, where the past market movements can significantly influence the future trend. By utilizing the LSTM, we can exploit the temporal pattern and the trend in the historical stock market data, enabling the model to make accurate prediction of the future price movement. And the second one is ANN. It stands for Artificial Neural Network, serves as a foundational deep learning architecture comprising of interconnected layer of neurons. In our project, we employ ANN as a benchmark model to compare its performance with the other architecture. Although specifically designed for the sequential data like time series, ANN allows us to gain the sight into how well it can adopt the stock market prediction task. Its interconnected nature enables it to learn the complex relationship in the data by analyzing the ANN performance and gauge the relative strength and the weakness of the more specialized model. And the third one is simple RNN. It stands for Recurrent Neural Network. And the role in stock market prediction is to capture the temporal dependency within the data. While the sophisticated simple RNN can still prove the valuable in detecting the sequential pattern that influence the stock market movement. As historical stock market data often exhibit the temporal relationship, the simple RNN helps us understand how well the recurrent architecture can handle the such dependency in the prediction context. And the fourth one is GRU. GRU stands for Gated Recurrent Neural Unit. And here, this project, it plays a vital role in capturing the long-term dependency of similar to the LSTM. Its gating mechanism allows it to control the flow of information, enabling the model to retain the relevant historical information while filtering out the noise. This property makes the GRU suitable for the time series forecasting, including the stock market prediction, where long-term trends significantly impact the future price. By employing the GRU, we can explore which this architecture excels in modeling the temporal dependency and capturing the intricate dynamic of the stock market. And the next one is loss comparison graph. After constructing the model, we evaluate the performance by comparing the losses over the training epochs. A loss comparison graph visually represents the efficacy of each architecture in predicting the stock market movement. And the next one is training the model. With the model built, we process the trained them on the historical stock market data. The training process involves feeding the model with the sequence of past market data and comparing the prediction with the actual market price. The model parameters are adjusted through the propagation to minimize the prediction error. And the sixth one is the given input is pre-processed for prediction. The user facilitate the input is pre-processed to align the format used during the model training. Pre-processing involves handling the missing value, standardizing the data, and converting the input to the suitable form for prediction. And the next one is using the trained model for the prediction. Here, the pre-processed input is fed into the trained model for the stock market prediction. Each model processes the input and generates the forecast for the specified date. And the last one is final outcome is displayed. The final outcome, which includes the prediction for the stock market on the specified date, is displayed to the user through the interface. This outcome provides the valuable insight for the investors and the traders, enabling them to make the informed decision and navigate the complexity of the stock market with that confidence. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder containing of various files within it. The data folder containing of the data sets that we used in this project, and the static folder containing of the folders like of CSS, JavaScript, stocks and images within it, and the template folder containing of HTML documents within it. It likely include about, home, index, layout, sign in and sign up and stock detail pages within it. And the app is an py file which likely contains the algorithm's information within it and as of front-end logic. It includes the code written in Python that handle the server-side operation such as processing the user requests, interacting with the database and generating the dynamic content that to be rendered in the HTML template. And model is an file which contains the algorithm information and it loaded into the project code during the runtime to utilize a trainer model for the various tasks, such as making the prediction on the new data or performing the specific operation. And the notebook is an IPYNB file which contains a combination of code, graph, and output all in one place. It allows the user to write and execute the code and the individual cell, making it a popular choice for the data science. And signup.db is a file appeared to be the database file used to store the user information. And to execute the project, we built the Flask framework as a front end, and the total code as a combination of the graph and output all in one place is present in IPYNB file named notebook. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here, first we need to change the location of the disk to F because our code folder is present in F disk. Then write a command that is cd space and paste this code folder path. By this it will change the directory to the code folder path. And then write a command to the python space app.py. By using this command, it will execute the Python script and perform a runtime check for the syntax errors or the logical issues. And then click on app.py file. By this, the framework will host the application locally at the default address like this. And here we need to copy this local link and paste it on any of the web browser, and I prefer to use the Google Chrome. Here we need to copy this link and then click on enter button. Here we redirected to the page containing of the title of the project and of about and the services we do. And here click on the sign up button. We redirected to the sign up page containing of the necessary details that are need to be filled. And my account is already generated, that's why I'm using the sign in button. Here we redirected to the username and password and we need to be filled. And I'm entering the username as of admin and password too. And then click on the sign in button. Here we redirected to the index page containing of the title and we need to enter the stock symbol. By this it will get the prediction of the stock market, and I'm entering of AAPL as of the enter symbol and then click on the search button. Here the stock market is predicted for the AAPL as of like this, and the predicted price is of this, and the accuracy of the prediction is of 98%. And then click on back button and the refresh button. Here we enter the another one as GOOGL and then click on search button. Here it redirected to the result as of the stock market prediction for the GOOGL, and it used the predicted price as of $1161 and the accuracy of the prediction is 97%. In this way we can predict the stock market by using various deep learning algorithms. And this is the loss comparison graph where x-axis represents the loss and the y-axis represents the algorithms we used in this project. And in our conclusion, our project has successfully achieved its objective of developing a sophisticated and accurate stock market prediction system by harnessing the power of advanced deep learning algorithms including LSTM, ANN, simple RNN and GRU. We have created a robust predictive model that effectively analyze the historical market data and forecast the future price trend. Through extensive evaluation and optimization, our system demonstrated impressive capability in making informed prediction, providing the valuable insight for the traders and the investors. The integration of the deep learning algorithms has proven to be highly advantageous, outperforming the traditional stock market prediction method. As a result, our project contributes to enhance the financial decision making, minimizing the risk, and maximize the return for the stockholders and the stock market. Moving forward, this work laid the groundwork for the further advancement in predictive analytics, revolutionizing the way traders and the investors navigate the dynamic world of the stock market with a greater confidence and success.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Project's YouTube channel and subscribe.